Good morning, dear students. How are you all? Fine. Okay, so this is a video of class 11, and in this video we are going to talk about the chemical properties of alkenes. And in the very first slide you can see that we are going to talk about the hydration. Hydration means addition of water, but this would be in the gaseous state. When we are actually talking that water which is actually reacting at very high temperature, that one is 300 degrees C, and at 60 atmospheric pressure in the presence of concentrated H3PO4. H3PO4, that one is phosphoric acid, and that one will act as a catalyst. So every time what it will give, it will actually give you this. You can see that H2O, it can break down into H plus and OH minus. Again this H plus will come and attack at this first position, and OH negative will go and attack on this position. So here the product you can get this CH3. Earlier it was CO2. Whenever the bond will break down, means pi bond is the loosely bond, and that will break down, it will every time attach one hydrogen at this position and one hydroxide at this position. So you will get this product. Okay, what is this product? 2 carbon ethane, single bond is there, ethane plus ol at first position. So you have to remove E, and you can see ethanol would be there. Okay, now we will move to the next slide. Here you can see that addition of hydrogen halide, that means HX. Commonly we have written X as the halogen, and X can be the Cl, Br or iodine. We are not going to talk about the fluorine, because fluorine actually forms the hydrogen bond, and that due to the highest electronegativity of the fluorine, we are not going to dissociate its bonds easily, because its bond dissociation energy would be very high. So we can say that here we have to react the alkenes with the different type of alkyl halide. Alkyl halide, not HCl, Hi and HBr. So here the very first reaction you can see that it is written CH2 double bond, CH2 double bond, CH2 plus HCl. This is negative, this one is positive. So we have actually discussed about this one, that if the symmetrical alkene would be there, then no problem is there. Anywhere you can add the hydrogen. In this one you can see hydrogen you can add on this position, bromine you can add on this second position. So ultimately you will get this product. Okay, if you will add hydrogen iodide, no problem with that one, you will get the similar product, nothing problem with that one. Okay, but the problem would come in the unsymmetrical alkenes. Okay na? But here the symmetrical alkene, what is the meaning of symmetrical alkenes? Symmetrical alkene mean that equal number of hydrogen is placed over there. If I am talking about the double bond, okay na? Double bond, left hand side one carbon is there, right hand side one carbon is there. If I will take the butene example, and if the double bond is present at the second position, after the second position, second to third carbon, that means we can say that every time it will be the double bond, and this should be the equal number of carbon every time. Okay na? So that one actually comes in the symmetrical carbon chain. Okay, now we will see next thing. Okay, so in this video we are going to talk about the addition of water in the chemical properties of alkene, and that one the addition of water. Okay, so here we will actually write that addition of water. Every time there will be some of the catalyst, and that one is H2SO4. We are taking the H2SO4. Okay na? So here few drop of concentrated H2SO4, that one is sulfuric acid, we are taking for the addition of water. So here we can see that CH2 double bond is there, CH double bond, CH and H is there. So what will happen if I will add H2 here? So this H2O I can write H plus OH minus in the presence of H plus means from the concentrated H2SO4 I can dissociate this into like this one. Okay, 2H plus. So here you can see the H plus is there. Now how it will react? H plus, this one will come at this position, OH negative will come at this position. So what you will get? CH, H and OH. So this one is the addition of H2SO4. If I will see the second example of this case, we can take the propene. Okay, now? So here we are taking the example of 2-methyl propene. C double bond C, here H2 at this position, 1 CH3 group is there. Okay, now? So 2, 1, 3, 4 CH3. I have taken 2-methyl propene, and in this one you can see that when I will react it with the water, okay, I will react it with water in the presence of H plus. What it will form? It will form. Yes, you can see that H2O I can break H plus OH minus. Okay, now this H plus will go and react on to this position. Okay, now so what it will form? It will form CH3 because you know double bond will break down. So it will form CH3, and here this carbon I have taken like this one, and CH3 I have taken like this one. CH3, and I have added OH here, and the symmetrical alkene is there, there is no issue, and CH2, one hydrogen will be added on to this one, so it will give this product. Okay, now so 2-methyl propene is actually changed into 2-methyl propane 2-ol. 2-methyl propane 2-ol, single bond is there, 2-methyl propane 2-ol. Okay, now 1, 2, 3, 1, 2, 3, either way you can take at the both position. 2-methyl is there, 2-methyl long chain propane, and at the second position ol is there. So 2-ol will be the answer. 2-methyl propane 2-ol. Now we will talk about the addition of oxygen, or we can say that oxidation reaction. Oxidation of alkene. Oxidation of alkene. So here you can see that if I have some unsaturated hydrocarbon, CH2 double bond CH2 I have taken. If I am talking about the oxidation of alkenes, so every time it is actually happens in the terms in the presence of Bayer's reagent. Bayer's reagent. Okay, now so this Bayer's reagent. Okay, Bayer's reagent, this one is actually cold dilute aqueous solution of KMnO4. Okay, now? So this one is the Bayer's reagent. Now actually this reaction actually takes place in the presence of that reagent. So I will take a nascent oxygen O plus H2O, and every time what it will give glycol. What is glycol? You can see that one oxygen is there. How can I write like this one? O plus OH negative. One O combined, H combined, that means O2 H2 will be there, means it can be written like OH and OH. So symmetrical alkene is there, that means one OH will go at this position, one OH will go at this position, double bond will break down. So you can see CH2OH, CH2OH. This one is the glycol. Okay. If I will take the propene, what will happen? If I will take the propene instead of this alkene, so what will happen? So see the example. If I will take the propene, CH3, CH, double bond, CH2, and here I have taken that same reaction will be there, oxygen, nascent oxygen plus H2O in the presence of dilute, cold dilute, aqueous KMnO4. This one is actually a test for unsaturation also. A test for, like the bromine you have done for the unsaturation, you can see that if the color would disappear in the case of bromine, that we can say this one which contains, that organic compounds contains double bond unsaturation. So this KMnO4 is also used to test that whether the compound is organic or not. So you can see here I have taken dilute KMnO4. Now what will happen? We know the same thing will be there from the reaction between these two. OH plus OH will be generated. So equal number of OH can be shared by the that carbon, double bonded carbon atom. So what it will form? It will form CH3, CH, CHOH, OH, CH2, OH. Now you can see whether the bond is satisfied or not. See, for this carbon, how can I write? CH3 or CH3, C, this hydrogen, this OH will come at this position, then second bond. So four bond is there for this carbon, and CH2, one hydrogen, OH. So both are satisfied. So hence we can see this product we will obtain, and here we have seen if I have taken the oxidation, I have done the oxidation, so nascent oxygen would be there. Okay, and then the reaction between the nascent oxygen and water will give hydroxide to both the carbon atom, which is actually around the double bond. Okay, na? So this one was the oxidation of alkenes. Okay, thank you.